take some more problems on the two-dimensional stress system. So just see this problem. So we have covered problems on finding tangential stress and normal stress on inclined plane, given the stresses in x, and directions and the shear stress. That means given the values of px, py, and q and theta, we know how to calculate the Pn and Pt values on that inclined plane, which makes an angle theta with vertical axis. That is one type of problem. Another type of problem we covered was given the values of Px, Py, Q, how to find the major principal stress as well as the minor principal stress, P1 and P2 values using the formulae, and also how to find the maximum shear stress and the respective planes. That means the principal plane directions as well as maximum shear plane directions. So we have understood that in the formula for that major and minor principal stresses, so between the two terms expressions, if you have plus sign, it is major principal stress. If you have minus sign, it is minor principal stress, P1 and P2. Then tan 2 theta is equal to 2q by px minus py. That formula we are using to find the direction of principal planes. You'll be having two values of theta there, which is having a difference of 90 degrees. Suppose if you get one value theta is equal to 45 degrees, the another value will be 45 plus 90, that is 135 degrees. So two principal planes will be there. On one plane, major principal stress will act. On the other plane, minor principal stress will act. That is P1 and P2. That's what we have discussed. Then maximum shear stress formula we know how to find. And the plane of maximum shear stress, once again, two planes will be there on which maximum shear stress acts. Those planes will be at 45 degrees to the principal planes. So these things we had discussed in the earlier classes. Now today we will see some more problems on that because you should understand the basic concepts clearly. So more number of problems if you work there, so you'll be confident. So just take this example. Show that sum of normal stresses in any two mutually perpendicular directions is constant in case of a general two-dimensional stress. This is like a derivation or a bookwork. So what does it mean? Sum of normal stresses on any two mutually perpendicular directions. So you take two directions, and if you add the normal stresses on those two mutually perpendicular directions, it will be a constant. So for that thing, what we will do is, let us consider a two-dimensional stress system in which Px and Py are the normal stresses and Q is the shearing stress. Thickness I will take as unity. So actually this
Sir,
derivation, yes, please.
sir, revision.
Huh?
ಇವತ್ತು ಲಾಸ್ಟ್ ಡೇ ಸರ್ ರಿವಿಷನ್ ಬೇಕಿತ್ತು.
ರಿವಿಷನ್ ಬೇಕಾ ಇವತ್ತು ನಿಮ್ಗೆ?
ಹಾ ಸರ್.
ಯಾವ್ದ್ರದ್ದು?
ಅಂದ್ರೆ ಸರ್ ಇವಾಗ ಟೆಸ್ಟಿಗೆ ಇರೋದು ಪೋರ್ಷನ್.
ಇದು ಉಂಟಲ್ಲ, ಟೆಸ್ಟ್ ಉಂಟಿದೆ.
ಅಲ್ಲ ಸರ್, ಪೋರ್ಷನ್ ಎಷ್ಟು?
ಪೋರ್ಷನ್ ಅದೇ ನಾನು ಆಕ್ಚುಲಿ ಇವತ್ತಿನ ತನಕ ಏನ್ ಮಾಡ್ತೀನಿ ಅಲ್ಲಿ ತನಕ ಇರ್ತದೆ. ವಾಟ್ ಇಸ್ ದಟ್ ಅಂದ್ರೆ 1.5 ಯೂನಿಟ್ಸ್. 1 ಯೂನಿಟ್ ಕಂಪ್ಲೀಟ್ ಸಿಂಪಲ್ ಸೈನ್ಸ್ ಮಾಡ್ಯೂಲ್ 1 ಫುಲ್ ಇದೆ, ಅದು ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ದೀನಲ್ಲ. ಮಾಡ್ಯೂಲ್ 1 ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ಮಾಡ್ಯೂಲ್ 2 ನಲ್ಲಿ ಈಗ ನಾನು ನಿನ್ನೆ ತನಕ ಎಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿಸಿದೀನಿ ಅದು ನೋಡ್ಕೊಳ್ಳಿ, ಮತ್ತೆ ಇವತ್ತು ಮಾಡೋದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡೋದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ, ಮಾರ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. ನಿಮಗೆ ರಿವಿಷನ್ ಬೇಕಂದ್ರೆ ಮಧ್ಯಾಹ್ನ ಮಾಡ್ತೀನಿ. 3:15 ಕ್ಲಾಸ್ ಉಂಟಲ್ಲ, ಬೇಕಾದ್ರೆ ಅವಾಗ ಹೇಳ್ತೀನಿ ನಾನು, ಆಯ್ತಾ? ಸೊ ಅಂದ್ರೆ ಜಸ್ಟ್ ಎಷ್ಟಾಗುತ್ತೋ ಅಷ್ಟು ರಿವೈಸ್ ಮಾಡ್ತೀನಿ ನಾನು. ಯೂನಿಟ್ 1 ಅಂಡ್ ಯೂನಿಟ್ 2 ಎರಡು, ಮಾಡ್ಯೂಲ್ 1 ಅಂಡ್ ಮಾಡ್ಯೂಲ್ 2 ಆಗ್ಬೋದಾ? ರಿವಿಷನ್ ಮಧ್ಯಾಹ್ನ ಮಾಡ್ತೀನಿ, ಆಯ್ತಾ? ಈಗ ಒಂದ್ ಎರಡು ಮೂರು ಪ್ರಾಬ್ಲಮ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಲಿಕ್ಕಿದೆ, ಅದನ್ನ ಮಾಡ್ಬಿಡ್ತೀನಿ, ಆಯ್ತಾ? ಆಫ್ಟರ್ನೂನ್ ಕ್ಲಾಸ್ ಆಲ್ ಆಫ್ ಯು ಜಾಯಿನ್, ಐ ವಿಲ್ ಜಸ್ಟ್ ರಿವೈಸ್. ಸೊ ಒಂದು ರಿವೈಸ್ ಮಾಡೋಣ ಎಲ್ಲ. ಫಸ್ಟ್ ಯೂನಿಟ್, ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ಅಂಡ್ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ರಿವೈಸ್ ಮಾಡೋಣ. ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲ್ ಬೇಡ ಅಲ್ಲ, ಈಗ ಆಲ್ರೆಡಿ ರೀಸೆಂಟ್ಲಿ ವಿ ಹ್ಯಾವ್ ಡನ್ ಅಲ್ಲ. ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ರಿವೈಸ್ ಮಾಡೋಣ. ಓಕೆ, ಆಫ್ಟರ್ನೂನ್ ಮಾಡ್ತೀನಿ, 3:15 ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡ್ತೀನಿ. See, this is one of the questions which has appeared in the examination also. ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾನೆ ಅಂದ್ರೆ, ಇಲ್ಲಿ what the meaning of this is, Suppose if you are finding normal stresses Pn value on any two mutually perpendicular directions, it is always a constant. So for that you have to use the same diagram to derive this 11.3a ಅಂದ್ರೆ ಯಾವುದು ಅದೇನೆ two dimensional system diagram px py and q. So tensile we are taking px and py as tensile 11.3a. You can just see that diagram. All these notes are there with you. You can just see the diagram. 11.3a is this. See, this is 11.3a. So that is the first diagram which we have used to derive the expression for idu, which we have used to derive the expression for the Pn and Pt value. So this is the diagram. So what we have taken px tensile, py tensile, q shear stress. So all are positive. Px, py, and q, they are all positive here. So what is done is the first step is same. So what we are doing, let us consider a plane, DE plane. DE plane I will consider. On this DE plane, these are the expressions for the normal stress. This is the expression for the normal stress that we have proved already. So this, so one plane is DE plane. Another plane, what we have to take? We have to take 90 degrees to this. So mutually perpendicular means you add 90 degrees to this. So that means one more plane we have to take on which the angle is theta plus 90. Okay. So first expression. So on this plane, this is the normal stress. So this we have derived already. I need not. You have to derive in the exam. You have to derive, but here I need not explain because all these steps are same. Next, what we have to do is you replace this theta by theta plus 90 because we are finding the Raghav, ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು ಅನ್ನೋದು ಬನ್ನಿ ಇಲ್ಲಿ PDF ಓಪನ್ ಆಗ್ತಾ ಇಲ್ಲ. ನೆಟ್ ಇದೆ ಮತ್ತೆ ಶೇರ್ ಮಾಡ್ಬೇಕಾ? One second, I will just open that file. So we know how to find the normal stress on an inclined plane, Pn expression. One more plane, if you take at right angles to that, what we have to do is that theta should be replaced by 90 plus theta or theta plus 90. That's all in the same expression. And we have to simplify that. Then we have to add both the values of Pn. So you can prove that that is a constant. If you add them, you are going to get a constant. So that's what it has to be done. Simple exercise. Yes. So you see here what has been done. Yes, see here. So this is the on that plane which makes an angle theta with the vertical face. This is the expression for Pn. This is what we have derived. So up to this we have already derived. So but you have to derive in the exam if they ask this. So Pn is Px plus Py by 2 plus Px minus Py by 2 into cos 2 theta plus 2q sin 2 theta. So this is the formula used to find the normal stress on an inclined plane. Now what he says is there is another plane which is at right angles to this CD, that is which is at right angles to that theta plane. That means theta dash. I take that angle as theta dash, which is theta plus 90. Hence, from the above general expression for stress on an inclined plane, we get. So what we have to do is in this formula, we have to put theta is equal to theta dash. So that means then we are going to get the normal stress on a plane which is 90 degrees to this plane. Okay, just replace theta by theta dash, where theta dash is theta plus 90. That's what has been done here. See, theta is replaced by theta plus 90. Here also theta is replaced by theta plus 90. Here what you will get? Cos 180 plus 2 theta. So cos 180 plus 2 theta is minus cos 2 theta. So that's why minus has come here. See, then sine 180 plus 2 theta, once again it is minus sine 2 theta. So minus q sine 2 theta it becomes. So this is the expression for the normal stress on a plane which is at right angles to the theta plane. Then you add these two. So sum of the normal stresses, Pn plus Pn dash. So what you will get? So this is plus, this is minus, gets cancels. This is plus, this is minus, gets cancels. So only you will be left with Px plus Py. Px plus Py divided by 2 plus Px plus Py divided by 2, which becomes Px plus Py. So in a given problem, Px and Py are constants. So maybe tensile or compressive. So just then Px plus Py is another constant. That means the sum of normal stresses in any two mutually perpendicular planes is constant and is equal to Px plus Py. So very simple derivation. The first part of the derivation we have already done by taking that sketch of element subjected to two-dimensional stress Px, Py and Q. And in the second part, replace that theta by theta plus 90 because he has asked normal stress on a plane which is right angles to that initial plane. So just replace that theta by theta plus 90 and use the trigonometric formula and then add the LHS of both the things. RHS becomes Px plus Py. So this is what we had to do. So if you add the normal stresses on two mutually perpendicular planes, you are going to get Px plus Py. So this holds good. For example, let us say if you take x-axis and y-axis, they are the planes. X-axis and y-axis, they are perpendicular to each other, as you know. So Px and Py, they are perpendicular to each other. So if you add the normal stresses on the x-axis, that is Px is one normal stress, Py is another normal stress. So if you take x-axis and y-axis itself as the planes, then sum will be Px plus Py. That's all. Okay, so it holds good for any value of theta. What I mean to say is, if theta is 0, if theta is equal to 0 degrees, what happens? Theta is equal to 0 means it is vertical plane because theta is measured from the vertical with respect to y-axis. So if theta is 0 means it is vertical plane only. So if you put theta is equal to 0 here, so what happens? Cos 0, this becomes cos 0, this becomes sin 0. So what happens? If it becomes cos 0, then cos 0 is 1. So it becomes Px minus Py by 2 only. Whereas this term becomes 0. Whereas if you add 90 to that 0, it will be 90 degree. Then it becomes cos 2 theta. Cos 2 theta means it is cos 180. Cos 180. Then sin 180. So cos 180 is 0. Sin 180 is 0. Whereas cos 180 is minus 1. Then if you add this and that, you will get same value. Px plus Py only. You can just check it up. Just take theta is equal to 0 and another value theta is equal to 90. So then you can check that. Then also you are going to get Pn plus Pn dash is equal to Px plus Py only. Yeah, that is about that. Next problem you see here is a different type of problem. Understand this problem. A material has strength in tension, compression and shear as 30 Newton per mm square, 90 Newton per mm square and 25 Newton per mm square respectively. That means he has given all the three stresses. Strength. Strength means that is that much you can apply the load. So tensile strength is 30 Newton per mm square.
Sir,
Compressive, yes, please.
sir, sin 180 0 alva, sir.
Oh, sin 180 0. Cos 180 minus 1.
Sir, ಅದು ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಅರ್ಥ ಆಗಿಲ್ಲ. ಕಾಸ್ ಟು
ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ನೀವು ಥೀಟಾಗೆ. ಯಾವ್ದು ಗೊತ್ತಾ? ಈ ಪಿ ಎನ್ ಇದೆಯಲ್ಲ, ಈ ಪಿ ಎನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇದೆಯಲ್ಲ, ಇಲ್ಲಿಗೆ ಥೀಟಾ 0 ಹಾಕಿ. ಥೀಟಾ 0 ಹಾಕಿದ್ರೆ ಏನರ್ಥ? ವಾಟ್ ಇಸ್ ಥೀಟಾ? ಥೀಟಾ ಇಸ್ ಮೆಜರ್ಡ್ ಫ್ರಮ್ ವರ್ಟಿಕಲ್ ಅಲ್ವಾ ಆ ಫಿಗರ್ ಅಲ್ಲಿ? ಆ ಫಿಗರ್ ನೋಡಿ 11.3a ನಲ್ಲಿ. ಸೊ ಥೀಟಾ 0 ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ? ವಾಟ್ ಡಸ್ ಇಟ್ ಮೀನ್? ಇಟ್ ಇಸ್ ದಿ ವರ್ಟಿಕಲ್ ಪ್ಲೇನ್ ವಿಚ್ ಇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಪಿ ಎಕ್ಸ್. ಅವಾಗ ಥೀಟಾ 0 ಹಾಕಿದಾಗ ಇದು ಕಾಸ್ 0 1 ಆಗುತ್ತೆ. ಇದು ಬೇರೆ ಇದು 0 ಆಗ್ಬಿಡುತ್ತೆ. ಸೈನ್ 2 ಥೀಟಾ 0 ಆಗ್ಬಿಡುತ್ತೆ. ಅವಾಗ ಏನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ? ಪಿ ಎಕ್ಸ್ ಪ್ಲಸ್ ಪಿ ವೈ ಡಿವೈಡ್ ಬೈ 2 ಪ್ಲಸ್ ಪಿ ಎಕ್ಸ್ ಮೈನಸ್ ಪಿ ವೈ ಡಿವೈಡ್ ಬೈ 2 ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಅದು ಪಿ ಎಕ್ಸ್ ಮಾತ್ರ ಬರುತ್ತೆ ಅಲ್ವಾ? ಪಿ ವೈ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಲ್ಲ, ಪಿ ಎಕ್ಸ್ ಮಾತ್ರ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೇಕು, ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಯಾವ್ದಿರುತ್ತೆ, ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇರುತ್ತೆ. ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ಗೆ ಥೀಟಾ ಎಷ್ಟು ತಗೋಬೇಕು, 90 ತಗೋಬೇಕಲ್ವಾ? 90 ತಗೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಇದರಲ್ಲಿ ಥೀಟಾನ 90 ತಗೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಯಾವ್ದ್ರಲ್ಲಿ ಮಾಡ್ಬೇಕು, ಇದ್ರಲ್ಲಿ ಮಾಡಿ, ಈ ಈಕ್ವೇಶನ್ ಮಾಡಿ. ಅಲ್ಲ, ಇದ್ರಲ್ಲೇ ಆಕ್ಚುಲಿ 90 ತಗೊಂಡ್ರೆ ಇದ್ರಲ್ಲೇ ಮಾಡ್ಬೇಕು ನೀವು, ಗೊತ್ತಾಯ್ತಾ? ಒನ್ ಸೆಕೆಂಡ್, there is some problem with so what you have to do is, first you have to substitute theta is equal to 0. Second you have to substitute theta is equal to 90. ಆಗ cos 180 ಏನಾಗ್ತದೆ, 2 into 90 180 ಬರುತ್ತೆ. cos 180 will be -1. ಆಯ್ತಾ? sin 180 0ನೇ ಆಗುತ್ತೆ, ಲಾಸ್ಟ್ ಟರ್ಮ್ 0ನೇ ಬರುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ನಿಮ್ಗೆ ಪಿ ವೈ ಬರುತ್ತೆ. ಅಲ್ಲಿ ಎರಡನೇದು ಪಿ ಎನ್ ಡ್ಯಾಶ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ವೈ ಬರುತ್ತೆ, ಪಿ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಎಕ್ಸ್ ಬರುತ್ತೆ, ಪಿ ವೈ ಇಸ್ ಈಕ್ವಲ್ ಟು P n dash is equal to Py, you will get. If you add them, you will get Px plus Py. That's all. That is a simple substitution. That's all. Okay. Yes. In the next problem, see, he has given the values of tensile stress, compressive stress, and shear stress. So those three values he has given for a material. Then let us see what he has asked. So three values of stresses he has given. One is tensile stress. First one is tensile stress. Tensile stress value is how much he has given? He has given 30. 30 Newton per mm square is the tensile stress. Compressive stress 90 and shear stress 25 for a material. If a specimen of diameter 25 mm is tested in tension and compression, identify the failure surface and loads. See, this is another. Here he has given the strength of that material in all the three. Tension strength is 30 MPa, compression strength is 90 MPa, shear strength is 25 MPa. So if you apply this to that two-dimensional, so first let us take in tension. We have to consider each one separately. In tension, let axial direction be x direction. Since it is uniaxial loading, so here what happens? Only tension is acting. Let us say only tension force is acting. Then Px will be 30. Px will be 30, Py will be 0. There is no, we assume, let us take one by one. Only tension force is acting along the axis, first case. Only one stress is acting along x axis, that is Px is 30, tension is plus 30 ತಗೊಳ್ತೀವಿ. So Py is 0 ಆಗುತ್ತೆ, Q also 0 ಆಗ್ತದೆ. So only Px exits. When the material is subjected to full tensile stress, Px value is 30. Substitute ಮಾಡಿ, ಮೇಜರ್ ಸ್ಟ್ರೆಸ್ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ. ಮೇಜರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಫಾರ್ಮುಲಾ ಗೊತ್ತಲ್ಲ ನಿಮ್ಗೆ, Px plus Py divided by 2 plus square root of Px minus Py divided by 2 whole square plus Q square. ಇದು ಫಾರ್ಮುಲಾ, ಮೇಜರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಇದು P1. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ Py is 0, Q is 0, only Px ಮಾತ್ರ. So you will be getting 30 ನೇ ಬರುತ್ತೆ ಆನ್ಸರ್. So P1 is equal to 30. Major principal stress when material is subjected to only tension is 30 Newton per mm square. Minor principal stress 0 ಆಗುತ್ತೆ. So because in the middle we have to take minus sign, it becomes 0. Q max ಏನು, maximum shear stress in that case, it is Px minus Py by 2 ಅಥವಾ P1 minus P2 by 2 ಅದು ಆಗ್ತದೆ. So it becomes 15. ನೋಡಿ ಇಲ್ಲಿ 15, our shear strength, how much shear strength he has given? He has given 25 Newton per mm square as the shear strength. Shear strength of that material is 25 Newton per mm square. What do you mean by that? Strength ಅಂದ್ರೆ ಏನು? It is the internal resistance that is going to develop. So that is expressed in terms of stress. So up to 25 Newton per mm square, that material can take the shear force. That is the meaning. If it exceeds that, then it will fail. So up to 30 Newton per mm square, the material can take tensile strength, tensile force. If it exceeds that, it will fail. Up to 90 Newton per mm square, the material can take compressive force. If it exceeds more than that 90, ಯಾವುದೋ ಒಂದು ಲೋಡ್ ಇರುತ್ತೆ, ಕಂಪ್ರೆಸಿವ್ ಲೋಡ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್, ಲೆಟ್ ಅಸ್ ಸೇ 10 kilonewton you are applying. Up to 10 when it is 10 kilonewton, let us say the compressive stress is 90. If it is more than 10 kilonewton, then it will fail. So the material will get cracks, it will fail. That is the meaning. This is maximum strength. Maximum strength in tension, maximum strength in compression, maximum strength in shear. That we are comparing. Now in the first case, when the material is subjected, ನೋಡಿ ಇದು figure, this is the figure. So this is the specimen. Only in one direction it is acting. Of course, ಇದನ್ನ horizontal ಆಗಿ ತಗೊಳ್ಬಹುದು, vertical ಆಗಿ ತಗೊಳ್ಬಹುದು. Here he has shown vertically. The specimen is taken vertically. So this is the direction over which the px is acting. ನೀವೇನಂದ್ರೆ ಇದನ್ನ px ಅಂತ ತಗೊಳ್ತೀವಿ ನಾವು ಅಷ್ಟೇ. ಸೊ ಇದನ್ನ ಹಾರಿಜೆಂಟಲ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ, ಏನ್ ತೊಂದರೆ ಇಲ್ಲ. ಸೊ ಹಾರಿಜೆಂಟಲ್ ಆಗಿ ತಗೊಂಡ್ರೆ ಯೂನಿಯಾಕ್ಸಿಯಲ್ ಸ್ಟ್ರೆಸ್ ಇದು. ವೈ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as ಯೂನಿಯಾಕ್ಸಿಯಲ್ ಸ್ಟ್ರೆಸ್? ಬಿಕಾಸ್ ದಿ ಸ್ಟ್ರೆಸ್ ಇಸ್ ಗಿವನ್ ಓನ್ಲಿ ಇನ್ ಒನ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಇಲ್ಲಿ ಬೇರೆ ಯಾವ್ದಿಲ್ಲ, ಪಿ ಎಕ್ಸ್ ಮಾತ್ರ ಇದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಪಿ ಎಕ್ಸ್. ಸೊ ಪಿ ಎಕ್ಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ವರ್ಟಿಕಲ್ ತಗೊಂಡ್ರಿಂದ ಇದು ಪಿ ಎಕ್ಸ್ ಆಗ್ತದೆ. ನೀವು ಹಾರಿಜೆಂಟಲ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ, ತಪ್ಪೇನಿಲ್ಲ. ಸೊ ವೆನ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಕ್ಯೂ ಮ್ಯಾಕ್ಸ್, ಯು ಆರ್ ಗೆಟಿಂಗ್ 15. ಸೊ ಬಟ್ ಯುವರ್ ಶಿಯರ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದಟ್ ಮೆಟೀರಿಯಲ್ ಇಸ್ 25. ನೋಡಿ ಅದು 15 ಲೆಸ್ ದನ್ 25 ಅಂದ್ರೆ ಸೇಫ್ ಅಂತ ಆಯ್ತು ಅಲ್ಲಿಗೆ. ಹೆನ್ಸ್ ಫೇಲ್ಯೂರ್ ಕ್ರೈಟೀರಿಯಾ ಇಸ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್, ದಟ್ ಇಸ್ P1 is equal to 30 Newton per mm square. ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಟ್ರೆಸ್ ಎಷ್ಟು? 30 Newton per mm square ಬಂದಿದೆ ಇದರಲ್ಲಿ. ಯಾವುದು? ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್. ಸೊ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಕಂಪೇರ್ ಮಾಡಿ. ಸೊ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಮೋರ್, 30 Newton per mm square. ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇಸ್ 25. ಓಕೆ, ಕೊಟ್ಟಿರೋದು. ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ 15. ಸೊ ಅದರಿಂದ ಫೇಲ್ಯೂರ್ ಕ್ರೈಟೀರಿಯಾ ಏನಾಗ್ತದೆ? ಸೊ ಸಿನ್ಸ್ ಇಟ್ ಈಸ್ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಬೇಕು ನಾವು. ಸೊ 30 Newton per mm square. ಸೊ ಲೋಡ್ ಏನಾಗುತ್ತೆ? ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಲೋಡ್. ಸೊ ಲೋಡ್ is given by, we know that stress is equal to load divided by area. 25 mm is the diameter. So area ಏನಾಗುತ್ತೆ? pi by 4 into 25 square millimeter square ಆಗುತ್ತೆ. So P we have to take now 30. ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಬೇಕು ಅಷ್ಟೇ. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ಅಮಾಂಗ್ ದಿ ಶಿಯರ್ ಅಂಡ್ ಅಮಾಂಗ್ ದಿ ಟೆನ್ಷನ್ ಯು ಟೇಕ್ ದಿ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ. ಸೊ 30 ಮತ್ತೆ 25 ನಲ್ಲಿ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ 30, ಅದನ್ನ ತಗೊಳ್ಳಿ. ಸೊ 30 is equal to ಇಷ್ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಪಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬರ್ತದೆ ಅಂದ್ರೆ ಫೇಲ್ಯೂರ್ ಸರ್ಫೇಸ್ ಇಸ್ ಗಿವನ್ ಬೈ ದಿ ಪ್ಲೇನ್ ಆಫ್ P1. ಸೊ P1 ಹೆಂಗೆ ಆಕ್ಟ್ ಆಗುತ್ತೆ? ಸೊ ಹೀಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಹೀಗಿರುತ್ತೆ P1. ಅರ್ಥ ಆಯ್ತಾ? ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರುತ್ತೆ. ಸೊ ಇದು ಆನ್ಸರ್. ದಿಸ್ ಮಚ್ ಲೋಡ್ ಇಟ್ ಕ್ಯಾನ್ ಟೇಕ್ ಇನ್ ದಿ ಫಸ್ಟ್ ಕೇಸ್. ಯಾವಾಗ? ವೆನ್ Px is equal to 30 Newton per mm square ಅಪ್ ಟು ದಿಸ್ ಲೋಡ್ ಎಷ್ಟು ಬರುತ್ತೆ? ಇದು ಕಿಲೋ ನ್ಯೂಟನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 14.726 ಕಿಲೋ ನ್ಯೂಟನ್. 14,726 Newton divided by 1000, 14.726 kilonewton. Up to 14.726 kilonewton, the material can take load. If the load is more than that, it fails. That is the main thing. Second case ಅಲ್ಲಿ ಏನು ಗೊತ್ತಾ? ಕಂಪ್ರೆಷನ್ ಟೆಸ್ಟ್ ಅಪ್ಲೈ ಮಾಡೋಣ. When the material is subjected to compression, ನೋಡಿ ಇಲ್ಲಿ ತಗೊಳ್ಳಿ. ನೋಡಿ ಕಂಪ್ರೆಷನ್ ಅಂದ್ರೆ ಹೀಗೆ, towards the arrow is towards the ಇದು. So only ಈಗ ಏನು what we have to take now? Px is minus 90 ತಗೋಬೇಕು ಈಗ. So suppose if the material is subjected to compressive stress means it is minus 90. ಎಷ್ಟು? minus 90 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. The strength of compressive stress is 90 here. So Px we have to take minus 90. Py 0 ಆಗುತ್ತೆ. Q is also 0. So what we are doing is we are testing the specimen in three cases. One only tension, second one only compression, third one only shear. ಮೂರಕ್ಕೂ ಟೆಸ್ಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಲೋಡ್ ಆಫ್ ಫೇಲ್ಯೂರ್ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್. ದಟ್ಸ್ ಆಲ್. ಸೊ ಹಿಯರ್ Px is minus 90 ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಕಂಪ್ರೆಷನ್. ಸೊ ಏನಾಗ್ತದೆ? ಸೊ ಅಟ್ ಫೇಲ್ಯೂರ್ ವೆನ್ Px is equal to minus 90 ಆದಾಗ ಲೋಡ್ ಏನಾಗುತ್ತೆ? ದಿಸ್ ಮಚ್ ಇಸ್ ದಿ ಲೋಡ್. ಸಪೋಸ್ ವಿ ಅಸ್ಯೂಮ್ ದಟ್ ಇಟ್ ಫೇಲ್ಸ್ ಬೈ ಕಂಪ್ರೆಷನ್, ದೆನ್ this much is the compressive load that can be applied. If it exceeds more than this, it will fail. Corresponding shear, maximum shear ಏನಾಗುತ್ತೆ ನೋಡಿ, ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ ನಿಮಗೆ 45 ಬರುತ್ತೆ. 45 ಬರುತ್ತೆ ನೋಡಿ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ? ಇಲ್ಲಿ 45 Newton per mm square is greater than 25 ಇದೆ. ಗ್ರೇಟರ್ than 25 ಇರೋದ್ರಿಂದ ಶಿಯರ್ ಅಲ್ಲಿ ಫೇಲ್ ಆಗ್ತದೆ. ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ ಈಸ್ ಎಕ್ಸೀಡಿಂಗ್ ದಿ ಶಿಯರ್ ಸ್ಟ್ರೆಂತ್. ಗಾಟ್ ಇಟ್? So when the stress exceeds the strength, it will fail. So that is the idea. When the stress exceeds the strength, it will fail. So what we have done is, assuming the value of Px as minus 90, Py as 0 and Q as 0, by calculating Q max, we got 45 Newton per mm square, which is greater than the shear strength. When it is greater than the shear strength, then stress is greater than strength. So when stress is greater than strength, it will fail. So ಅದಕ್ಕೆ ನೋಡಿ ಅವನು ಏನು ಹೇಳ್ತಾನೆ? ಮೆಟೀರಿಯಲ್ ಫೇಲ್ಸ್ ಬಿಕಾಸ್ ಆಫ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಶಿಯರ್ and not by axial compression. So ಅವಾಗ then what we have to do is, let us calculate the reverse way ನಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು ನಾವು ಲೋಡ್ ನ. ಹೇಗೆ ಅಂದ್ರೆ Qmax, once again you apply the formula for Qmax, substitute the values. So Px is, Py is 0, Q is 0, you will get Px by 2 barutte Qmax ge. Athwa Px is equal to 2 times Qmax. 2 times Qmax andre 2 times 25. 2 times 25, 50 Newton per mm square. Andre it can take only up to 50 Newton per mm square the compressive stress. ಇದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು ನೀವು. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದೀವಿ, ಫಸ್ಟ್ Qmax we have calculated, maximum shear force we have calculated. Then we observed that maximum stress is greater than the strength of shear strength. That means it fails by shear, not by compression. Taking that it fails by shear, once again you back substitute and get the value of the corresponding compressive stress. So compressive stress value is 25 Newton per mm square is the shear strength. We can see that this Px value should be 2 times Qmax, which is nothing but 25 given in the problem. So it can take only up to 50. So it can take only up to 50 Newton per mm square the compressive stress value. That is the meaning. ಇದಕ್ಕೆ load calculate ಮಾಡಬೇಕು. Corresponding load we have to calculate for this. So if you calculate corresponding load for this, so ಇದನ್ನ stress ಅಂತ ತಗೊಳ್ಬೇಕು. So stress is equal to load divided by area. So load, corresponding load, so 50 is equal to P divided by area. Area is pi by 4 into 25 square for that material. So P calculate ಮಾಡಿ 24,543 Newton ಬರುತ್ತೆ. That is 24.543 kilonewton ಆಗುತ್ತೆ. ನೋಡಿ ಈ ಪ್ರಾಬ್ಲಮ್ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ನೀವು. ಇಲ್ಲಿ ಏನಂದ್ರೆ shear calculate ಮಾಡಿ, maximum shear you calculate. Maximum shear is exceeding the shear strength. When maximum shear exceeds the shear strength, it fails by shear only. Fails by shear. Corresponding value of Px you calculate. Back substitution ಮಾಡಿ you calculate the corresponding value of compressive stress that can be carried. Then for that calculate the corresponding load P by A. So 50 ಬರುತ್ತೆ. Up to 50 this material can take compressive. 90 ತಕೊಳ್ಳಲ್ಲ ಅಂತ. That is the meaning. 90 Newton per mm square it cannot take. It fails before it fails by compression. It fails by shear. It fails by shear. So each material has got its strength in three things: tensile, compressive, and shear. It may fail in one of the cases. So it may fail by tension, it may fail by compression, or it may fail by shear. So that's why in RCC we are using two materials. One is concrete, another is steel. Steel is strong in tension, concrete is strong in compression. So it will balance. So when you apply the load, what happens? Steel and concrete, steel is very strong in tension. It can take more tensile load. Concrete is very strong in compression. It can take more compression load. On the building, you'll be having lot of compressive forces, lot of tensile forces, lot of shear forces, torsion forces. Everything will be there on the building. So when you are going to design the building, if you are using RCC, so both tension and compression will be taken care, and both concrete and steel they are strong in shear also. ಎರಡು shear strong ಇರುತ್ತೆ. So ಹಾಗಾಗಿ that is why that RCC material is used. That you are going to study in detail in your 5th semester design of RCC. Next ಇದರಲ್ಲಿ plane, ಯಾವ plane ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ ಇದು? ಯಾಕೆ since your the failure is occurring at maximum shear, we know that maximum shear plane is at 45 degrees to the plane of Px. So ಅದರಿಂದ ಏನಾಗ್ತದೆ ಇಲ್ಲಿ 45 degree angle ತೋರಿಸಬೇಕು. ಇದು shear failure plane ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಮೂರನೇ ಕೇಸ್ shear stress ತಗೊಳ್ಬೇಕು. ಥರ್ಡ್ ಕೇಸ್ shear stress ಬೇಕಾಗಿಲ್ಲ. He has not done it. Only two cases. ಅಂದ್ರೆ he has compared that shear with compression and tension. So first case only tension force is acting. In that case your maximum value of shear stress you are getting Qmax as 15, which is less than 25. So therefore the failure occurs due to normal stress only. So other value ತಕೊಂಡು calculate ಮಾಡಬೇಕು. In the second case, when it is subjected to compressive stress, you are getting maximum shear stress more than 25. That is 45 ಬರ್ತಾ ಇದೆ. So when you are getting that, so it fails by shear, and corresponding compressive stress, so maximum compressive stress that the material can take becomes 50. Back substitution, if you do, you will get 50, and for that you have to calculate the corresponding load. Since the maximum shear stress plane makes an angle 45 degree with Px value, so the failure plane will be at 45 degrees. So that's what is the explanation of this problem. And I think this problem I have explained already. Problem number 3 over. 4 also I had explained. Let us see. Then fifth fifth problem. This is very important. I explained how to draw the planes. So P1 plane, P2 plane, they are mutually perpendicular. 90 degrees the angle, and Qmax planes will be at 45 degree to the P1 and P2 plane. Maximum shear plane. ಅದನ್ನ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಟೆಸ್ಟ್ ಅಲ್ಲಿ ಕೂಡ ಕೇಳ್ತೇನೆ ನಾನು. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದಿ ಸ್ಕೆಚ್ ದಿ planes. This problem also I had explained. So these are all the problems with the different data. Tension, compression vary ಮಾಡಿರೋದು. Resultant stress find out ಮಾಡೋದು. So this also I had explained. Next, let us see what I have to do. I think from here onwards, I have to take it. Yeah. This problem, 11.8, simple problem. Show that when a material is subjected to shearing stresses and unidirectional direct stress, the major and minor principal stresses are of opposite nature. So very simple. What is this? Is subjected to shear stress. Shear stress is there. Q value will be there. And unidirectional direct stress andre eno? Unidirectional direct stress andre only Px will be there. Py will be 0. So biaxial. So there is another word. You can make a note of that. Uniaxial or biaxial. Uniaxial means only Px will be there or Py will be there. One of them will be there, other will be 0. Okay. Biaxial means both of them will be there. Px also will be there, Py also will be there. And sometimes they may give shear stress, sometimes they may not give shear stress. If they give shear stress, you have to take it as Q. If they don't give, you have to take Q as 0. That's all. Now in this problem, it is a unidirectional direct stress. Okay, unidirectional direct stress means only Px is there, Py is 0. Q is also there, subjected to shearing stress as given. Q is also there. So let Q be the shearing stress. Now major principal stress. What is the formula for major principal stress? P1 is equal to Px plus Py by 2 plus root of Px minus Py by 2 whole square plus Q square. Here Py you have to take 0. If you put Py 0, you are going to get like this. Similarly, P2 will be with a negative sign in between. That's all. Instead of plus, minus will come. Okay. Now what he says, the major and minor principles are of opposite nature. So these two are of opposite nature. How do you say that they are of opposite nature? Opposite nature means if one is tensile, another one will be compressive. That is the meaning. Okay. If one is positive, another will be negative. So from here you can see, if you observe the expressions, here in the first one, P1 is equal to Px by 2 plus root of Px by 2 whole square plus Q square. You can see that both are positive here. Both the terms are positive here. Let us take positive root of this. So this is also positive number. This is also positive number. So positive plus positive is another positive. So that means since this here P1 is positive. Actually here the second term is more than the first term. Why? Because it is root of Px by 2 whole square plus Q square is there. So that means if it is only Px by 2 whole square, if you take the root of that, you will get Px by 2 only. Then it will be equal. But here it is not equal. It is greater than that. It will be greater than that. So Px by 2 whole square plus Q square is greater than Px by 2 whole square naturally. So in that case, first in the when you are writing that P1, both the first and second term they are positive, and if you add them, the sum is also a positive term. Whereas in the second one, P2, you can observe there, first term is Px by 2, second term is root of Px by 2 whole square plus Q square, but in between minus sign is there. So since it is minus sign is there, since second term is more than the first term, naturally it will be negative. P2 will be negative. So it is something like 2 minus 3, like that. So whereas in the first case it is 2 plus 3. 2 minus 3, 2 plus 3. So like that. So I will give a numerical example, then you will understand. So in the first case, see P1 you got, P1 is equal to, you got this. Let us take some numerical values. So Px is some, let us take 1. Q is also 1. Then what happens? This is 1 by 2 plus root of 1 by 2 square plus 1 square. Whereas here, this is 1 by 2 whole square plus 1 square means, if you take the root of that, that will be greater than this. So this term is more than this term. So that's why when you subtract, this becomes a negative quantity. So that is the meaning of this. The major and minor principal stresses are having opposite nature. So if P1 is positive, P2 will be negative. So this is what I wanted to tell. So main types of problems. So two types, important two types of problems are there in this. One is given the px, py and q values and theta, find the normal stress and shear stress or tangential stress on inclined plane by knowing the value of theta. That is one type of problem. Then also how to find the resultant stress. So resultant stress is given by square root of Pn square plus Pt square. So that is one type of problem. Second type of problem is given the values of Px, Py and Q, how to find major principal stress P1 and minor principal stress P2 and the principal plane directions theta values. Two theta values will be there. Tan 2 theta is equal to that formula we have to use 2q by px minus py. You will get two values of theta. One value, if it is two values of theta which differ by 90 degrees. Okay, if one value is 40 degree, another value will be 130 degree. They are the directions of the principal planes, P1 plane and P2 plane. Next, coming to maximum shear stress, they may ask you to find the maximum shear stress, Qmax, and also direction of the planes on which those maximum shear stress acts. So that we have proved that the planes of maximum shear will be at 45 degrees with the principal planes. So that also we have done. So those two types of problem. Today I explained one more problem in which a specimen is subjected to only tension, only compression, and shear strength is given. What is its failure load? What is the load at failure or the maximum load that material can take? So that type of problem also I had explained, and some two book works on any two mutually perpendicular planes. The normal stresses, the sum of the normal stresses is always constant. That is Pn plus Pn dash is equal to Px plus Py. So those things I explained today. So anyway, in the afternoon class, I will revise the first unit, the module. Whatever I have explained, just I will go through quickly. So you can just attend that class. And whatever assignments I have given, 15 problems I have given in module 1, you have to submit by Monday. I have not given any problem in module 2, but it is there. So the pattern will be like this. 4 questions, that is 40 marks will come from module 1. 10 marks will come from module 2. Okay. So 10 marks I am going to give from this compound stresses, 40 marks from the simple stresses and strains. In that you have to study all the things. So tapering bar is there, then in that circular section is there, rectangular section is there, then compound bars subjected to temperature stresses, simple bars subject to temperature stresses, then elastic constraints, relationship between elastic constraints, problems on elastic constraints, Hooke's law, generalized Hooke's law. Okay, so problems on finding change in volume and all those things I have covered. A lot of problems I have done. So you have to go through that. Then compound bars problem, that also you have to. Then tension test subjected to, yes, tell me.
Sir. Sir,
Postpone
assignment
ಮಾಡ್ಬೇಕು ಯಾಕೆ? ನೀವು ಟೆಸ್ಟ್ ಓದಿರ್ತೀರಲ್ಲ.
Sir, exam.
ಹೌದು, ಅದಕ್ಕೆ ನಾನು ಕೊಟ್ಟದ್ದು. ನೀವು ಅದನ್ನ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಟೆಸ್ಟ್ ಯೂಸ್ ಆಗ್ತದೆ ಅಂತಾನೆ ಕೊಟ್ಟದ್ದು. ಅದೆಲ್ಲ ಮಾಡಿ ಅಂತಾನೆ ಕೊಟ್ಟದ್ದು ನಾನು. ಮಾಡಿ ಟೈಮ್ ಉಂಟಲ್ಲ, 3 days.
Sir, ಮಾಡಿದ್ದೆ ಸರ್, ಸಬ್ಮಿಟ್ ಮಾಡ.
ಅದು ಇದು ಮಾಡುತ್ತಾನೆ, ನೀವು ಮೇಲ್ ಮಾಡುತ್ತಾನೆ. ನನಗೆ ಮೇಲ್ ಮಾಡೋದು ಅಷ್ಟೇ, ನೀವು ಸಾಫ್ಟ್ ಕಾಪಿ ಫೋಟೋ ತೆಗೆದು ಮೇಲ್ ಮಾಡೋದು, ಅದಾಗೋದಿಲ್ವಾ? ಅಲ್ಲ, ನೀವು ಫೋಟೋ ತೆಗೆದು ನನಗೆ ಮೇಲ್ ಮಾಡ್ಬೇಕಷ್ಟೇ. ಯಾವತ್ತು ಸಬ್ಮಿಟ್ ಮಾಡ್ತೀರಾ ಹಾಗಾದ್ರೆ?
ಸರ್ 19 ಸರ್
19th ತುಂಬಾ ಲೇಟ್ ಆಗ್ತದೆ.
18 ಮಾಡ್ತೀವಿ.
ಅಲ್ಲಲ್ಲ, ನೀವೆಲ್ಲ ಮಾಡಿಟ್ಟಿರ್ತೀರಿ ಅಲ್ವಾ? ಈಗ ನಾಳಿದ ತನಕ ಎಲ್ಲ ರೆಡಿ ಮಾಡ್ತೀರಿ ಅಲ್ವಾ? ಯು ವಿಲ್ ಬಿ ಸಾಲ್ವಿಂಗ್ ಆಲ್ ದಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೈ ಮಂಡೇ. ಮಾಡ್ಲೇಬೇಕಲ್ಲ ನೀವು ಟೆಸ್ಟ್ಗೆ. ನೀವು ಟೆಸ್ಟ್ಗೆ ಓದ್ಬೇಕಾದ್ರೆ ಅದನ್ನೆಲ್ಲ ಮಾಡ್ಬೇಕು, ಗೊತ್ತಾಯ್ತಾ? ನಾನು ಅದರಲ್ಲೂ ಕ್ವಶನ್ ಕೊಡ್ಬೋದು, ಅದು ಹೇಳಲಿಕ್ಕಲ್ಲ, ಸೀಕ್ರೆಟ್ ಅದು, ಗೊತ್ತಿಲ್ಲ ನನಗೆ. 15 ಕ್ವಶನ್ಸ್ ನಾನು ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, ದಿನಕ್ಕೆ 3 ಮಾಡಿದ್ರೆ ಆಗೋಗುತ್ತಪ್ಪ. ನಾನು ಮೊನ್ನೆನೇ ಕೊಟ್ಟನಲ್ಲ ನಿಮಗೆ. 5 days ಟೈಮ್ ಇದೆ. 3 ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿದ್ರೆ ಹೋಗ್ತದೆ 15 ಪ್ರಾಬ್ಲಮ್ಸ್.
ಸರ್ ಬೇರೆದು
ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ,
ಹಾ
ಗೊತ್ತಿಲ್ಲ.
ಸರ್.
ಕೊಟ್ಟಿದ್ದಾರೆ. ಒಂದು ಕೆಲಸ ಮಾಡಿ, ನೀವು ಮಂಡೇ ಟ್ಯೂಸ್ಡೇ ವೆಡ್ನೆಸ್ಡೇ ಮುಗಿದ್ರೆ ಥರ್ಸ್ಡೇ ಸಬ್ಮಿಟ್ ಮಾಡಿ ಹೋಗಿ, ಆಗ್ಬೋದಾ? ಅಥವಾ ಫ್ರೈಡೇ ಮಾಡಿ.
ಹಾ
ಫ್ರೈಡೇ ಎಷ್ಟು
Friday.
ತಾರೀಕು?
Friday,
ಫ್ರೈಡೇ
okay.
16th ಅಲ್ಲ? ಓಕೆ, 16th ಯು ಸಬ್ಮಿಟ್. ಆಮೇಲೆ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಕೇಳಬಾರ್ದು. 16th
ಇಲ್ಲ
ಸಬ್ಮಿಟ್ ಮಾಡಿ, ಫ್ರೈಡೇ ಸಬ್ಮಿಟ್. ಓಕೆ, ಸೊ ದೆನ್ ಮಧ್ಯಾಹ್ನ ಮೀಟ್ ಮಾಡೋಣ. ನಿಮ್ಗೆ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಎಲ್ಲ ಕೇಳ್ಕೊಳ್ಳಿ ಮಧ್ಯಾಹ್ನ. ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ರಿವಿಷನ್ ಕ್ಲಾಸ್ ಅದು ಮಧ್ಯಾಹ್ನದ್ದು, ಟೆಸ್ಟ್ಗೆ ಯೂಸ್ ಆಗ್ತದೆ ನಿಮಗೆ. ಓಕೆ, ಸೊ ಲೆಟ್ ಮಿ ಟೇಕ್ ದಿ ಅಟೆಂಡೆನ್ಸ್. 15 ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೆ ಅಷ್ಟೇ. ಓಕೆ, 19002 ಅಭಿಷೇಕ್.
Yes, sir.
003 ಅಜಯ್ ಕುಮಾರ್. ಅಜಯ್ ಕುಮಾರ್. ಆಬ್ಸೆಂಟಾ? ಆನ್ ಮಾಡಿ ಎಲ್ಲ ಹೋದ್ರೆ ಆಬ್ಸೆಂಟ್ ಅದು. ದರ್ಶನ್ 005.
Present, sir.
006 ದಿವ್ಯಶ್ರೀ.
Present, sir.
007 ಜಾಹ್ನವಿ.
Present, sir.
009 ನಿಶಾಂತ್.
Present, sir.
Next 10 Padma.
Present, sir.
Then 11 Preeti.
Present, sir.
12 Rahul.
Present, sir.
13 Medhesh.
Present, sir.
16 Sri Lakshmi. 7 Sri Lakshmi.
Present, sir.
17 Shreyas.
Present, sir.
Present, sir.
17 Shreyas ಅಲ್ಲ? 18
Present, sir.
another Shreyas. 19 Shweta.
Present, sir.
21 Surya.
Yes, sir.
Okay, morning I have mailed. I think all of you might have received that mail. Your group mail I have sent one more book. So ಅದು RK Bansal ಅದು ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್. ನಿಮಗೆ ಯಾವ್ದು ಮಾಡಿದೆ ಅದನ್ನ ಮಾತ್ರ ನೋಡ್ಕೋಬೇಕು ನೀವು, ಅರ್ಥ ಆಯ್ತಾ? ಪ್ರಾಬ್ಲಮ್ಸ್ ವರ್ಕೌಟ್ ಮಾಡಿದೆ ಇನ್ ದಟ್ ಬುಕ್. ಆಲ್ಸೋ ಲಾಟ್ ಆಫ್ ವರ್ಕ್ಡ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಹ್ಯಾವ್ ಬಿನ್ ಡನ್ ಅಂಡ್ ಎಕ್ಸರ್ಸೈಸ್ ಆಲ್ಸೋ ಸಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆರ್ ಗಿವನ್. Just whenever you find time, just go on practicing. Notations you be careful because I have used PX, PY, Q ಇಲ್ಲಿ in my notes. In that book sigma x sigma y ಟೋ ಅಂತ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ, ನೋಡ್ಕೊಳ್ಳಿ ಅದು ಕರೆಕ್ಟ್ ಆಗಿ. ಸ್ಟ್ರೆಸಸ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಸಿಗ್ಮಾ ವೈ ಟೋ ಅಂತ ಕಾಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ ಕೆಲವು ಬುಕ್ ಅಲ್ಲಿ. ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಅಂದ್ರೆ ಪಿ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ ಅಂದ್ರೆ ಪಿ ವೈ, ಟೋ ಅಂದ್ರೆ ಕ್ಯೂ, ಆ ತರ ತಗೊಳ್ಳಿ, ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಈ ಸಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಹಿ ಹ್ಯಾಸ್ ಆಲ್ಸೋ ಸಾಲ್ವ್ಡ್. ಸೊ ಫಾರ್ ಯುವರ್ ಟೆಸ್ಟ್ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದೋಸ್ ಎಕ್ಸರ್ಸೈಸ್. ಬೇಕಾದಷ್ಟು ಆಗ್ತದೆ ನಿಮ್ಗೆ. ಸೊ ಪಾಠ ಮಾಡೋದನ್ನ ಅಟೆಂಟಿವ್ ಆಗಿ ಕೇಳಿ, ಮತ್ತೆ ಏನೇನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ಅದೇ ಪ್ರಾಬ್ಲಮ್ ವರ್ಕೌಟ್ ಮಾಡಿ ಅಸೈನ್ಮೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ ನ ನೀಟಾಗಿ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ. ಸೊ ಅಷ್ಟು ಮಾಡ್ಕೊಂಡ್ರೆ ಬೇಕಾದಷ್ಟು ನಿಮ್ಗೆ ಎಕ್ಸಾಮಿನೇಷನ್, ಆಯ್ತಾ? ಸೊ ದಟ್ಸ್ ವಾಟ್. ಓಕೆ, ವಿಲ್ ಮೀಟ್ ಇನ್ ದಿ ಆಫ್ಟರ್ನೂನ್.
Sir, CV30 present, sir. Network
CV
issue.
13
Ah,
13 ಅಲ್ವಾ? 13
30.
ಮೇಲೆ 30
Network issue ಇತ್ತು sir.
19 ಬ್ಯಾಚ್ ನೀವು?
18.
18 ಬ್ಯಾಚ್, 18030. ಸರಿ, ಓಕೆ, ಆಯ್ತು. ವಿಲ್ ಮೀಟ್ ಇನ್ ದಿ ಆಫ್ಟರ್ನೂನ್.
Sir, 003.
ಹಾಕಿದ್ದೀನಿ.
Okay.
003 ಆಗಿದೆ.